In this video, you'll learn how to add a data model, how to search and retrieve information from the data model environment of TRIADB framework, and how to visualize your data model. Let's begin. From the Jupyter file browser, we open the Add Supplier Part Catalog folder, and we select the Add SPC data model from JSON file. First, we restart the kernel, we read and clear the output, and then we start executing each cell by pressing Shift plus Enter. The full path location of data model has already been set for you. So in the next cell, we read the data model from a JSON file. This is what the format looks like. These are JSON serializable data for Network X graph, a Python library for studying Network X graphs. And here is an alternative view of the same file. Now back to our Jupyter notebook. We continue with the execution of the cells, of the next cell. Triad parses the JSON file and creates a hypernetwork X in memory. HNetX is an object handler in Triad framework that we can use to pass or get information for our network X hypergraph. Finally, we permanently store this data model by adding this hypergraph into Triad framework database. The output you see here is a mapping from entities and attributes of the data model environment onto hyperbond and hyperatom collections of a data set environment. Now we can search the database for a specific data model by passing a from and find arguments, and we can also specify that we want to return the result in the form of keys. Since we now know the ID of the model, we can ask for the entities and attributes from the same data model environment, abbreviated as DME. Python pandas tables reveal also the existing mapping from attributes of the model environment to collections of the data set environment. For example, the catalog price is mapped to a hyperatom collection of type real. If we want to take a more in-depth view of our data model as a hypergraph network, we can ask for the hyperlinks that connect entities to attributes, or you can say hyperedges to hypernodes. So here you see that the catalog entity is linked via a specific type of hyperlink to a number of attributes. Conversely, if we follow the inward direction from attribute to entity, we get the following table of records. And this is a bidirectional form of linkage, and the main difference here from other graph databases is that we can use any set of labels on the edges for semantic purposes. In order to visualize our data model as a hypergraph, we recreate the hypernetwork X graph in memory with the data we retrieved from the database. In summary, these are the two sets of hyperedges and hypernodes, and the other two sets of hyperlinks for the inward and outward directions. Now we can choose from a number of different visualizations. The first one you see here is with the Viz.js JavaScript library, and you can notice the bridge attributes that connect the supplier with the catalog and the catalog with the part. And these are the bridges here. And we continue to redraw our hypergraph with the GraphViz engine and the Neato graphics layout. This shows clearly the bidirectional nature of our graph. And the last two, we are using the Network X library for drawing GraphViz hypergraph networks with PyDot layout. And finally, we can ask Triad for an overview of the data model environment and inspect the existing models that have already been created and stored in the database. In the next video, we will see how you can add data resources.